Could a nuclear bomb move an asteroid? Imagine this. Somewhere in the endless dark, a massive rock is silently spinning toward Earth. No sound, no warning, just a cold trajectory. Billions of tons of stone and metal heading straight for our planet. Hollywood loves this story. A desperate team of astronauts, a nuclear bomb, a last minute detonation, and then fireworks in space. But if you strip away the cinematic drama, the question remains, could we actually do it? Could a nuclear bomb really move an asteroid? Let's start with scale. The asteroid that wiped out the dinosaurs, Chicxulub, was around 10 kilometers wide and hit Earth with the energy of about 100 million megatons of TNT. That's more than every nuclear weapon ever built combined. The largest bomb humans have ever detonated, the Tsar Bomba, produced 50 megatons. Impressive by human standards, but compared to an asteroid, it's like trying to push a mountain with a sneeze. But here's the interesting part. We don't actually need to destroy an asteroid. We just need to nudge it. Space is huge, and small changes in trajectory can make a massive difference over time. Imagine a bowling ball rolling toward the pin. If you give it a tiny tap early enough, it might miss the target entirely. That's the logic behind using a nuclear explosion not to blow up an asteroid, but to push it. There are two main ways a nuke could do that. The first is a direct hit, slamming the bomb right into the asteroid and detonating it on impact. The explosion would vaporize part of the asteroid's surface, creating a burst of gas and molten debris that acts like a rocket engine, pushing the rock slightly off course. The second and safer method is a standoff detonation. The bomb goes off a few hundred meters above the surface. This still vaporizes material, but without shattering the asteroid into hundreds of smaller but equally deadly pieces. After all, turning one asteroid into 1,000 flying bullets isn't exactly an improvement. So, does it work? In theory, yes. In practice, it depends entirely on timing and precision. The earlier we spot a threat, the less energy we need to deflect it. If an asteroid is decades away, even a small nudge could make it miss Earth by thousands of kilometers. But if we discover it only months before impact, even the biggest bomb might not be enough. Space agencies like NASA and ESA already track thousands of near-Earth objects, and they've developed something called the Planetary Defense Strategy. Part of that plan actually includes nuclear options, but as a last resort. In 2022, NASA tested a much gentler method. The DART mission, Double Asteroid Redirection Test, deliberately crashed a spacecraft into a small asteroid called the Dimorphos. The impact was tiny, but it changed the asteroid's orbit by 33 minutes. That's proof that even a relatively small push, if applied early enough, can work. If we scale that up with nuclear power, the results could be dramatic. But there's a catch. Asteroids aren't all the same. Some are solid rock, some are metal, and some are just loose collections of dust and gravel held together by gravity, so-called rubble piles. If you hit a rubble pile with a nuke, it might just absorb the energy like a sponge, barely moving. Worse, if you detonate too close, it could disintegrate, and those fragments might still be on a collision course with Earth. In that case, we wouldn't face a one impact, but a shotgun blast of smaller ones, each still powerful enough to destroy cities or entire regions. There's also the problem of delivery, getting a nuclear device safely into orbit, guiding it across millions of kilometers, and timing its detonation perfectly. All of that is far more complicated than it sounds. Even a small navigation error could cause the mission to fail completely. And politically, launching nuclear weapons into space is, well, controversial. The 1967 Outer Space Treaty actually bans the deployment of nuclear arms beyond Earth's atmosphere. So before we save the world, we'd have to rewrite international law. Still, the physics doesn't lie. A nuclear explosion releases immense energy, millions of times more powerful than chemical rockets. If used correctly, that energy could push an asteroid just enough to make the difference between a near miss and extinction. It's not a guaranteed plan, but it's better than nothing. And there's something poetic about it too. For the first time in history, humanity has both the power to destroy itself and the potential to protect its own planet. A nuclear bomb, built for war, could one day become a tool for survival, a weapon turned into a shield. So, could a nuclear bomb move an asteroid? The answer is yes, but only if we are careful, early, and incredibly lucky. Because space doesn't care about human heroism or movie endings. It's just physics, gravity, and time. And if that deadly rock ever really comes our way, all we can do is hope that our calculations and our courage are enough to push it aside.